All right, guys. Happy Tuesday. Good morning to y'all. We're going to do a quick recap of ropes, the finalizing of them, and then we'll move into um, hardware and the combination of that, and then do PPE inspections as far as helmets, safety glasses, hearing protection, stuff like that. Okay, cool. All right. So, as I always do, I like to go back over the course of what we've done and ask questions. So this time, you guys ask me questions of what you've learned and see if I can answer them. Don't make me call on you guys. Yes.
Class 1 or Class 2 core development.
Class 2. Okay. Why?
Why?
Yeah.
Yeah.
I just answered. Oh, why?
Yeah.
Okay. Class 2 is core dependent because it has aramid fibers or HMPE fibers in the middle of it. The cover is just specifically for abrasion and UV resistance. Cool.
What is the only rope that you can use with a biting hand ascender as your life support?
Good question. What is the only hand ascender I can use that's got teeth, so tooth cammed, in life support?
Yeah.
Kern mantle.
Yeah.
Okay, and Kern mantle because the core is parallel fibers on that, and so when you fall, the teeth can ride down that. They're not going to rip the double braid up. Good question. Good question. Good. All right. Next. Come on, I'm gonna start calling on y'all. We talked about inspection, splices, configurations, constructions, applications. There's not all rope is created equal. The reduction of what? Rope length, usually like 6 inches. 60%.
If it's a half inch.
Up to 6%. I have no idea. It's going to be less than what the rope is rated for.
60% reduced or 60% retained?
Retained, yes, thank you. Yep. So 40% in reduction, 60% retained strength. Good question. Come on. Who else? Did a month of this stuff.
Why do we use the aramid fiber for the winch?
Okay. So we use aramid fibers over your synthetics, which is going to be the polyester and nylons because of the stretch and then also the strength. And then also too, we didn't touch on it, is aramid fibers have a better abrasion resistance than the polyester and nylons do.
Do they have the same like bend ratio?
Yes.
Like if you were to redirect it to the way.
Yeah. So the big D over little d, you're talking about? Yeah. So that's going to be. We didn't talk about that, did we? We're going to do that when we get into rigging. So basically, there's a formula: big D over little d. And I think when we were discussing it, that's where Daniel Arce got his nickname, Big D. So it looks like this, or they'll do something like that. What you want is a 4-to-1 ratio when you're going over a sheave on your pulley or a surface. So what that means is if I have a 1/2 inch diameter rope, okay, what size sheave is ideal? Very good, Linda. 2 inches. Okay, so that's the optimum working length. You're still going to have strength loss in that, but that is the ideal. If you're going to have to make a turn, you want a 4-to-1. Obviously, anything bigger than that is better, right? Now, the question is why? Right, Brian? Why? Why when we make a turn with a rope is there strength loss? Yes, but why? The rope is bendy. Not absolutely about the fibers. Think about it. Remember we talked about testing?
Different points of pressure on the rope. Can't like fully extend graceful strength.
Okay. Yeah, you're getting warm. Yeah, you're getting warmer. Yeah, you're getting warmer. Yeah, go ahead, Dan. Okay, that has to do with it, yeah, but there's specific reasons why. You guys are getting close. You're sneaking up on it. Elongation, the fiber stretchiness. Right, what's happening at a turn? Okay, so say that again.
Rope's meant to be pulled away from itself.
You're close. You're close. There's a little more to that, right? Because technically you're pulling when it goes over a pulley. It's rolling over a sheave. Yeah. What's happening at the change of direction? Well, there's some friction, yeah.
Tension and compression.
What's that?
Tension and compression.
Tension and compression. Very good, Jacob. Gold star. Okay. What does that mean? What does that mean, right? Brian? I'm going to pick on you now. Yeah. What's that? Well, yes, we know that, but why? You get a bronze star. All right. So like Luke said, right? Rope is meant to be pulled straight. Right? Let's see if I can make a pretty rope here. Is that pretty? All right, I'm not an artist. I'm an arborist. Okay. So over the top, right? We have a change in direction. Okay. Instead of the fibers, when they remember in the video, they're all laid together with the bobbins. It all comes together up to the little thing at the top, right? And that's what forms a rope. They're all equal and balanced. Okay. So the second that these are pulled in different directions, we're pulling more side. We're having more tension on one side of the strands than we are on the other, right? So we're gonna have more tension on this top side because these ones here are stretching over, right? They're being pulled apart more over the top. Okay, right? So it's an unequal load force at this point. We're not pulling 100% of the diameter of the rope. We're pulling less than that. Okay, so if I were to look at the top of a rope, sorry, I'm gonna jump in the way. As it goes, right? So here's the pulley. Okay. If I'm looking at the top, we can just say half of this right here is being stretched. Okay, and this side right here is being compressed. Okay, so we have an unequal load force that's being pulled across the plane of the rope. So it's unequal. There's an unequal load force basically of the rope. Okay, does that make sense? So we're going to get stretching out of that.
You would have changed the angle at which it ran through. Like instead of a 90 like that, 45.
Yeah. Yeah. So obviously the most extreme, right? 90, or I mean a 180-degree turn. And then as you open that angle up, right, it's decreasing the load that's on there.
On the rope as well?
On the rope as well, yeah. So both the force, when we get into rigging, we'll talk about that, the sling angles, how this plays part into that. Okay. So what's happening? So the top side, right, is getting tension. We're pulling more. The underside is getting compressed because now those fibers are being pushed in, right, from the top ones being overloaded, the other ones are being pushed in, and that sometimes creates a lot of heat, which, as you guys know, what's the word? that happens to a rope when heat is applied?
Glaze?
Glazing happens, yes, okay. The other, degradation. Degradation.
Bigger word.
Bigger word, yeah, bigger word. Degradation, okay. Yeah. So we get degradation, right? So heat loss. Do you guys remember what the temperature of degradation is for your nylons and polyesters? At what temperature it starts to degrade, lose its strength?
300.
Less than 300. I like that answer. Yep, less than 300 degrees Fahrenheit. How quickly can we generate 300? Pretty quick. Pretty quick, okay? Cool. Okay, what are the two types of ice splices? That is a style. Okay, sewn
Braided.
and braided, okay, or hand sewn or hand splice. Yeah. Okay, good. You are, but you guys aren't coming up with questions. Okay. I think you guys got ropes pretty good. Maybe.
For that diagram, is that apply to any type of rope?
Any
Even 3-strand will still have, it's not as comparable to like a 24 grade or something like that, or is it all?
I would imagine it's a good question. I would imagine there's a different percentage as far as the change in direction, as far as what the strength loss is, but all of them will experience it. So, yeah, that's a good question though. I don't know what that number would be if it was a 3-strand compared to a 32-strand, right? Obviously, you know, that's where you get into the 16-strand having a cord knot. See how that one is round over the load? Some ropes flatten out. So that flattening out actually decreases the amount of tension that's on the top side, which is going to keep its strength over the change in direction. But some hardware, you don't want it to flatten out. Okay? Okay, cool. One more question, or what about, ask me a question about inspection. We can cover inspection.
How often should you do it?
Before and after use, every day.
How many threads would you have, or how many cut strands would you have to have in a 32 strand?
3.2 strands within 6 inches of length of rope. Good question. Anybody else? That was cut strands. What else did we talk about? Brian, what you got for me?
For inspection.
Yep.
Percentage of material loss where you retire like a or a.
We didn't talk about hardware yet.
We did a little bit. You showed us those pulleys that have like a huge material loss in the roof.
Pulleys.
Yeah, the X-ring. X-ring.
Those aren't pulleys.
Those pulleys, yeah, the X-ring.
X-rings. Okay, yeah. In the hardware, 10% of the stock. Okay, good question. Okay. What about glazing? What about glazing? My rope's glazed. When do I retire it? Yeah, and then magically disappears. Yeah. Rub it on a tree. Yeah. What about glazing? What's the calculation for rope retirement? Come on, Josh. Also 10%. Good job, dude. Yep. 10%. See the theme there? 10%, 10%, 10%. Okay. Cool. All right. That's all of it, right? Yep.
Glove one? Stop wearing gloves.
Yeah.
Okay. But give me some key indicators that you guys found why we put stuff in the discard pile.
Mold.
Mold. All right. Very good. Yeah. Mold. Very good.
Expiration date.
Expiration dates. Okay. How did you find that expiration date, Miss Linda?
That one I think was underneath a wrap that had Velcro, and then it said the manufacturing date, and I looked online to see how long that company used. It said 5 years, and it was 7 years. 7-year-old.
Very good. Okay. So that's cheating. Right? That's wonderful. Okay. So we have an ultimate tool that we carry with us every single day. Okay. And I call it the Oracle. Currently it's videotaping right now, but it's your phone. We have access to all kinds of not so interesting stuff and some really interesting stuff. So based off of that, if you guys don't know, right, you can always do your research. Now, one thing that I didn't address that I'm going to start addressing now as I teach this class is AI. Okay. Do not rely on AI to give you the final answer for it. So if you ask ChatGPT or Gemini or those other ones that are out there, do not just assume that information is correct. Go straight to the manufacturer's website, look up the serial number or the part number itself, and get that information directly from the manufacturer themselves. Okay, that's a big thing. Don't just trust AI. Back it up. Look online from the manufacturer. Okay, because right, it's AI and it's faulty. It's been known to somewhat give inaccurate information sometimes. So I would not want inaccurate information when it comes to my life support system. I would rather have accurate information, okay? So your Oracle is a great resource for you guys to figure out. So she did it good. It had a manufacturer date. Okay, so that's the first thing you're going to look for, or one of the things you should look for, not the first, doesn't have to be in any order, is the date of manufacturing and figuring out what year is it expired. Okay, now, okay, so let's clarify real quick. Why would or what? How should I ask this? What component of harness would have an expiration of the harness? The textiles. Yeah, correct. Okay, so that's the webbing, the rope. That's going to have textiles. So okay, the nylon, polyesters, right? We talked about the aramids and the polymers and all of that stuff. UV is a big deal. Okay, so regardless of if it's brand new or not, harnesses have a shelf life, depending on what it's made of. Okay, and that's key. Okay, all right. So we'll keep that in our back of our mind.
So my saddle's expired, but I mostly bucket. I'm not storing it in the sun. I just feel like it's fine.
Who's the manufacturer?
Tree Motion.
And it's 8 years, right?
Yeah.
There's just 8 years. Did they change it to 7?
Oh, I thought the new one, or the old one was 7.
Yeah, I thought they were 8. Okay, so what year was it manufactured? Okay. So we'll get into that. Okay, and I'll explain why. I'm gonna try and like lead you guys into that so it sticks. Okay. Okay. So what about the metal side of things? Does that have a shelf life? No. Okay. As long as it passes inspection. Okay. So there's a couple criteria. If it's hardware, it's got to pass function. And when the inspection, it's got to pass inspection as far as corrosion, crazing, wear, and its original design. Crazing. So crazing. So crazing is like impact. And I'll have, when we get into hardware, which is going to be next week, we'll have some, not microscope, but pictures of what crazing looks like. It's an impact. It's not like a steady pool. There's a difference. It starts to like crusty. It gets crusty as the metal is like pulled apart. It's called crazing. Okay. So they have expirations. Okay. And they all have to be within the designs. Okay. For harnesses we're talking about, not for hardware. Hardware doesn't have an expiration. It just has to pass inspection. Okay. So, okay, with that, okay, it's original design. We'll just start with the fun one. Okay. So this is in the pass pile. Okay. Why did this pass? You couldn't figure out what was wrong with it, right? Okay. So again, if I don't know how to inspect something, where can I find out how to inspect it? Right? What does that say on there? Petzl, manufacturer. Okay. Usually there's a tag or the name of it. This is the Sequoia. Okay. Every few years, right, designs change. So you can look online and see if this is design or not. Okay. If this has got a webbing bridge, they went to a rope. That's a different design. Right. We've got the ring open. The newer ones just have the D. Okay. So there's also design changes. And then on all life support, there should be serial numbers or tracking numbers on that. Now I'm going to clarify and this is going to be tough. Okay. So if you're doing a competition, okay, if the serial and the tag is missing, your harness is ejected. Okay. Now, I am smart. You all are smart. Okay. I know on my harness when I bought it, and I know what model and style it is. Okay. So I know it's not expired. Okay. And let's just say my tag got ripped off. It's missing, right? Tree work is difficult. Okay. I know the model. I know my harness. I don't need to throw that harness away because the serial number and the tag is missing. Okay. So that's where I stand on that. Because to me, it just seems silly. And I get why, right? Why people do that. The last company I was at, it doesn't matter because they had 1,800 employees. And it's hard to be like, we're doing inspections on stuff. Your tag's missing. Well, I don't know what that's been through, where it's come from, right? I can research it, but I'm just going to eject that and give you a new one, okay, just to be on the safe side. But I like to educate you guys to do that on your own so that you, because I can't catch everything. It's not my job to inspect your gear. It's your guys' job. I don't need to babysit and play big brother and inspect your guys' gear for you. You guys should be inspecting your equipment and know how to do that, okay? That's what I think is more important than checking serial numbers, okay? So it does have expiration date, okay? Now, some manufacturers don't have expiration dates, okay? So if I want to know about this harness, okay, I can go to the manufacturer, I can check it out. So when I was doing the Petzl PPE instructor trainer class over at the Petzl Institute, Keith Luzinski was really nice to me, and this was a brand new, never been out of the bag harness. But this harness is expired. Okay, this is over 10 years old. Petzl has a 10-year shelf life. Okay, this has never been used. It's never been climbed on. It was stored in a warehouse, never touched, never out of the bag. But according to Petzl's recommendations, okay, and their safety standards, this harness is unfit for service. Okay, so this is expired, even though it's never been climbed on, never been used, pulled out of the bag, stored in a warehouse. Okay. The reason being is because of the textiles, like Linda mentioned earlier. Your nylons and your polyesters, regardless, unless they're in a 10-foot thick concrete structure, the second it's manufactured, the strength loss starts to degrade within those fibers. Okay, and that's all of them. So it doesn't matter if it's being used or not, there's going to be degradation within those fibers regardless of use. Okay, and that's why they have a shelf life. Those nylons and the polyesters will start to lose their strength and degrade over time to the point where you could actually just pull them apart because of the degradation process of it. Okay, so they usually always have an expiration 10, 7 or 8 if it's Teufelberger. On the tree motions, I believe Edelrid is in the 8-year mark as well. Okay, so usually if it's over 5 years, we're going to do some good inspections on it, keep track of it, and then refer back to the manufacturer. Okay, okay. Oh, sorry, I feel like you're gonna have a question. Okay, cool. All right. Now, this one kind of makes me nervous. Okay, who inspected these? I know some of you guys did. Who inspected these? Huh?
That was me and Daniel. One of
You and DG. It was this corner over here. Okay. So this one is still good. Okay. This one is not. All right. And so when we're inspecting, knowing your equipment is really, really, really important. Okay. The first obvious one is the hardware. Okay. So I physically did this stuff, okay, just to prove points for a class, for key things for you guys to pay attention to, okay? Right, so what can we tell about this ring? It's incomplete, okay? What's it missing? Okay, and that little black tab that's in there, right? Okay, so that's missing on this harness, okay? So that automatically, I can repair it and find a replacement ring for this, or I need to take out of service until I can get that replaced, okay? That's not meant for, so there's a difference, right? It's either can I repair it or replace the pieces, or does it need to go? Okay, so this will fall into I can repair or replace this, okay? Excuse me. Let's see, when we're inspecting, right, we want to make sure we move the webbing back and forth, okay? Because this is part of the life support, right? This webbing here is holding my leg in place. If I fall, I don't want to fall out of my harness, okay? So when we inspect, we need to move the pieces, okay? When on the buckles and everything, slide it back and forth. One, that's good so you don't get major wear spots, okay? The other thing is we're going to notice things that weren't there before. Let's see what on this side. Especially in harnesses, we get cuts in places, okay, from hand saws. Okay, so that would deem it, this is non-repairable and this harness is junk now. Okay,